Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
To manage the energy transition, it will also be important to rapidly develop cheap and efficient materials that can be used to split water or CO2 by electrocatalysis. In this process, part of the electrical energy is stored in the chemical reaction products. The efficiency of such electrocatalysts depends largely on the nature of the electrode-electrolyte interfaces, i.e., the interfaces between the solid electrodes and the typically aqueous electrolyte. However, spatially resolved physical studies of such solid-liquid interfaces are still relatively scarce. More insights with AFM Dr Christopher S. Kley and his team have now developed a new approach to correlative atomic force microscopy, AFM. An extremely sharp tip is scanned across the surface and its height profile is recorded. By attaching the tip to the end of a miniaturized cantilever, the force interactions between the tip and the sample surface, including frictional forces, can be measured with high sensitivity. In addition, the electrical current flowing through the mechanical contact can be measured, provided a voltage is applied. This allowed us to simultaneously determine the electrical conductivity, the mechanical chemical friction and the morphological properties in situ, i.e., under the relevant liquid phase conditions rather than in vacuum or in air, emphasizes Kley. Copper-gold electrocatalyst. Using this method, the scientists now studied a nanostructured and bimetallic copper-gold electrocatalyst in collaboration with Professor Beatriz Roldan Cuenya from the Fritz Haber Institute, FHI. Among others, such materials are used in the electrocatalytic conversion of CO2 into energy carriers. We were able to clearly identify islands of copper oxide with higher electrical resistance, but also grain boundaries and low conductivity regions in the hydration layer where the catalyst surface comes into contact with the aqueous electrolyte, says Dr. Martin Munz, first author of the study. Such results on catalyst-electrolyte interfaces help to optimize them in a targeted manner. We can now observe how local electrochemical environments influence charge transfer at the interface, says Kley. Focus on solid-liquid interfaces. However, our results are also of general interest to energy research, especially for the study of electrochemical conversion processes, which also play a role in battery systems. Insights into solid-liquid interfaces can also be useful in completely different area. This work was carried out within the framework of the CatLab project, where researchers from the HCB and the FHI of the MPG are working together to develop thin-film catalysts for the energy transition. Thanks for watching. Please subscribe my channel for more videos.